Here's the question that we're working on. We have a south pole of a magnet approaching a coil of wire, and notice that the coil is wound this way with the front side going to the ground of a voltage measurement machine, and then on the back side it comes off to the positive terminal of the voltage machine, DMM or a oscilloscope. Let's take a look here at our setup right here. We claim that this is the south pole of the magnet and this is the north pole. If that's true, the magnetic field line should go out of north and into south. I have a sensor right here that says the field coming out of it, going this direction, is positive. I'll pause and let you see that. Okay, so now what we want to do is go and look at our coil over here. And so the coil is set up. Here's the side on the front connected to ground. Here's the coil on the back side connected to a positive section. And now I'm going to move this towards there at constant speed. And before we do that, let's think if we just get the south pole a little bit closer, what should happen? Well, we have a magnetic field this way. If this coil could have an induced current, it would oppose that increase in magnetic flux that's pointing this way through the coil. Again, if I bring the south pole close to this, I'm adding magnetic flux this way. That means the coil would try to create a current, not necessarily succeed, but it should try to create a current that opposes that and have current flowing this way. That would correspond to this being a positive terminal and this being a negative, which is opposite the polarity of our measuring device. Therefore, we expect a negative bump on the screen, and we see that a little bit. Let me try you one more time here. We see that there's a negative bump on the screen. So now ask yourself, what should happen when I push the magnet through at constant speed? Should there be one bump, two bumps? Should they be negative, positive? How will they look? Okay, here we go. 1, 2, 3. All right. And as a bonus question, what should happen when I pull it backwards? So pause the video and think. Now I'm going to pull it backwards. Now we have a north pole approaching from this side and a south pole there, and we're going to pull it backwards. Okay, here we go. 1, 2, 3, go. It's the same. That's it.